Hello, this is Dr. Hassan Abdullah, and in this video we will cover the remaining part of the basics, that is the part of lecture 1A plus. And in the next lecture, which is lecture 1B, we will cover heuristics. That correct answer could be the shortest path between 2 points on a graph, and that correct answer could be a spanning tree and so on. So that has to be correct. And of course, if the answer is incorrect, if the result is incorrect, then the algorithm loses its purpose. So that is unacceptable. Then the efficiency is the time complexity, which is basically the polynomial time complexity we are looking at. And it matters for the large data sets. For example, if it's like order n log n, that is acceptable time complexity for large data sets. If the data set is a small one, a medium size, even smaller, then we are happy with bubble sort also, which is quadratic. So the time required to execute matters a lot. Okay. And for example, quicksort has a better average time complexity of order n log n as compared to bubble sort. Then is the space complexity, the space required to, so if it's in place sorting or it requires a separate data structure, then of course the space complexity is of course important when the size of the problem increases, and it should not consume more memory than necessary. Okay. So merge sort has a space complexity of order n, which is relatively efficient as compared to the algorithms like dynamic programming, because we need to store the partial results, for example, like the Dijkstra algorithm. So need to take all of this into consideration, and these are the expectations from an algorithm. Then is this fitness is the termination. The algorithm must always terminate, and it should terminate in a finite amount of time, and it should not go into an infinite loop. And if there is a recursion, there has to be a base case, which we will discuss in the corresponding part. So it should have a base case. It should not go into an infinite loop, and there should not be an infinite recursion. So that has to be there, of course. And then the simplicity. It should be easy to understand. It should be easy to implement. It should be easy to maintain. And of course, for example, if you look at binary search, so binary search is fairly straightforward to implement, to maintain, as opposed to the Floyd-Warshall algorithm. Finding the shortest path can be harder, right? And if it's harder to code and harder to implement, then it's harder to maintain also. But these are not some of the, these are the, this is what is expected. But the key things, the most important thing, that is it should give the correct answer. It should give the optimal answer. And in the next part of the basic section, we will look at the heuristics and the brute force approach, which of course heuristic is kind of opposite to an algorithm. So, some more characteristics of a good algorithm, it should be generality. Generality means that the algorithm should be like can be used, should be applicable for not to a specific type of data or specific domain, but it should be usable in other domains also. And of course, it should be scalable also. So, for example, sorting algorithms that can sort not just numbers but also objects that can be compared, like while bubble sort has specific application. Scalability is again linked with time complexity, so that if the size of the problem increases, the algorithm does not take lots and lots of time. So scalability is again linked with time complexity. For example, an order n cube algorithm for matrix multiplication is not scalable when the matrix size increases, as opposed to the Stressen method, which is order n power 2.8 for matrix multiplication. So order n square may work fine for small data sets, but when the data set size increases, then of course it is not acceptable. And robustness, that unusual conditions, and there could be conditional statements which take care of it. And of course, it is desirable and maintainable. Okay. So include ease of modification and debugging, which is comparable to the prior point which we've already discussed. Yeah, this is important. Determinism, unless the algorithm is randomized algorithm such as quicksort, in which which is not stable because of that randomization, so the algorithm should be deterministic. So if I have multiple runs of that algorithm, I should get the same answer, I should get the same result. So that is determinism, should produce the same output for the same input. And because for certain scenarios that consistency is critical. So bubble sort is stable sort, okay, which is deterministic, but quick sort is not deterministic because of the randomness of selecting the pivot. And of course, parallelism is desirable, and it is affordable now because of the availability of low-cost computing resources over the net. So, for example, merge sort is parallelizable, because different halves of the array can be processed across different processing units and so on. So this it is desirable, but of course, not all of the problems have this kind of a property, so that can be parallelized, and therefore there don't exist such algorithms also. So with this, we conclude this subtopic.